Welcome to the first of the videos going through the Chemistry PPE for 2021. This is paper 2. I'm going to go through a couple of questions at a time and we'll see how we go. I'm just going to get on with it. So question 1 here is a reasonably straightforward question. It's back titration question where a student wanted to work out how much magnesium hydroxide, which is a base, in an antacid tablet. Okay, so what they did is they took the magnesium hydroxide, reacted it with sulfuric acid, and they deliberately added an excess of sulfuric acid, and they worked out how much sulfuric acid was left over in a titration, and that allows them to work out how much magnesium hydroxide there was in the first place. Okay, so that's the process that's going on. The paper takes you through everything stage by stage. You don't need to know how to do a back titration from start to finish here. The first thing you have to do is to work out how much in moles of sulfuric acid there is. You know already that moles is equal to the volume times the concentration, or volume times concentration. We've got the volume here in centimetres cubed, so we need to divide by 1,000, and the concentration is 0.1. 0 moles per litre. Volume is 50 centimetres cubed over 1,000, and that equals 5.00 times 10 to the minus 3. I'd encourage you really here, there's quite a lot of people just wrote 5 times 10 to the minus 3 here. Please get into the habit of using the appropriate number of significant figures. Okay. Part B was a nice straightforward balancing equations question. So sulfuric acid reacts with magnesium hydroxide, and in order to be able to do this question you need to work out the formula of the product. The first product is obviously magnesium sulfate. Magnesium is a 2+ ion and sulfate is a 2- ion, so they just magnesium sulfate is that formula, and you get water produced as well, and if you balance it you'll find pretty straightforwardly that you need 2 waters there. Good students often did that with state symbols as well, but that wasn't essential for the mark. Okay. Right, this is where people start to slip up. So the excess sulfuric acid, so don't forget they added more sulfuric acid than they needed. The excess sulfuric acid was titrated against sodium hydroxide. So you know, don't you, that sodium hydroxide and sulfuric acid react in a titration to give sodium sulfate and water. In other words, they react in a 2:1 ratio. And so if you're going to try and find out how much sulfuric acid you had, you need to know how much sodium hydroxide you had. You've got 20.8 centimetres cubed, and you've got a concentration of 0.1133, and so I mean there's not a lot of room to make a full grid here, but let's just do that over here, shall we? So we've got number of moles of sodium hydroxide, n equals CV over 1,000, just like before. Of sodium hydroxide, that comes to 20.8 divided by, well, times 0.1133 over 1,000 is equal to 2.357 times 10 to the minus 3 moles. That's moles of sodium hydroxide, so we can put that in here maybe. N is equal to 2.357 times 10 to the minus 3. And then the moles of sulfuric acid are half that because they react in a 2:1 ratio, and that's the final answer. So if you just divide this by 2, and we get 1.178 times 10 to the minus 3, and that's the final answer there. That's the number of moles of sulfuric acid that were left at the end of this reaction. Okay, so we know from the top here how much sulfuric acid we started with, and we know how much sulfuric acid was left at the end. So to find out how much was used up in the initial stage when the student added sulfuric acid to magnesium hydroxide, we need to do one take away the other, and that's a common step in back titrations. You also have to do a taking away step. How much you started with, take away how much you ended up with. And that equals 3.82 times 10 to the minus 3 moles. And by this time we'd lost a few people. A few people were getting stuck at this point. Okay. Following that, we had to work out how much magnesium hydroxide there was. And if you remember from the balanced equation, just bringing this back up here, balanced equation, balanced equation shows that sulfuric acid and magnesium hydroxide react in a 1-to-1 ratio. So however much magnesium hydroxide we had, so we just said that the N of magnesium hydroxide is equal to the number of moles of sulfuric acid, which we just worked out in the previous question. So that must be 3.82 times 10 to the minus 3 as well. Okay. And the MR of magnesium hydroxide is equal to 58.33. Mass is equal to MR times moles, which is equal to 58.33 times 3.82 times 10 to the minus 3, and that equals, I'll put it up here, 0.223 grams. So that's how many grams of magnesium hydroxide there were. The next question most people got, it doesn't matter what you put here, whatever your answer was here, as long as you worked out a percentage of that into that, you were fine. So 0.223 divided by 1.24 times 100, that comes to 18.0%. So it's whatever mass it was here divided by that, the total mass of the tablet times 100 is 18%. And why was repeating quantitative measurements, why is that important? And there are a couple of tolerated answers for that. And the mark scheme says that you to reduce random errors, or to ensure reliability, or to increase precision. Okay, so I only gave marks for those three answers: to reduce random errors, to increase precision, or to ensure reliability. That's question 1 done.